Hello students, welcome to the classes. So in this session, we'll start with the chapter integration. Let's start with the chapter integration. Okay. So basically integration is what? Reverse process of differentiation. So integration is what? Reverse process of differentiation. Okay. Right. Now, how do you represent integration? Integration we represent using this symbol. Okay, so if I write integration of f of x dx, okay, this symbol represents integral or integration of some function. With respect to what variable you are integrating? We are integrating with respect to the variable x here. So this dx represents with respect to what variable we are integrating. Okay. So, and as I told, integration is reverse process of differentiation. This integration, that's why it's also called as antiderivative. It's also called as antiderivative. Okay. So now, as integration is reverse process of differentiation, hence it is called as antiderivative. Okay, now let's see, okay, how we can integrate few functions based on what? The reverse process of differentiation. What I mean is, okay, so we represent a derivative or using d by dx, right? So now d by dx of x square is what? Differentiation of x square is 2x. D by dx of, let's take x square plus 5 is what? Differentiation of x square is 2x. 5 is a constant, its differentiation is 0, so I will leave it. Now if you take d by dx of, let's say, x square minus 9, now x square differentiation 2x, 9 differentiation is 0, right? Now see, what you may have some constant here, right? So whatever the constant you have, its differentiation becomes 0. And as I told, integration is reverse process of differentiation. Now if you want to write integration of 2x with respect to x, now do you write x square, or do you write x square plus 5, or do you write x square minus 9? Which one you will write? See, I'll write what? X square. You may get some constant here, right? Because if you differentiate this constant, you are getting 0 here, right? So there may be some constant or there may not be some constant. Here there is no constant, means the constant value here is 0, right? The constant value here is 0. So I'll take plus some constant of integration as c, because differentiation of constant will lead to 0, as integration is reverse process of differentiation. You can see here differentiation of x square 2x, c is a constant, its differentiation is 0. That is why we always write some constant of integration c whenever we are integrating. Okay, such type of integrals are known as indefinite integrals, because here we are not mentioning any limits here. From where to where we are integrating, we are not mentioning the limits. Such type of integrals are known as what? Indefinite integrals. So now let's see a little about what indefinite and definite integrals. Now, there are two types of integrals. First one is indefinite integrals. Second is definite integrals. Second is definite integrals. Now, what is the difference between indefinite integrals and definite integrals? Now, if I take integration of f of x dx, this is indefinite integral. If I take integration of f of x dx and the value of x, because we are integrating with respect to x, the value of x, if it varies between, let's say, a to b, the value of x, it varies between, let's say, a to b. Now here you can see we are mentioning what here, we are mentioning the limits here. This is called as lower limit, this is called as upper limit. See here we are mentioning the limits here, lower limit and upper limit. So we are giving some limits from where to where we should integrate. They are called as definite integrals. In indefinite integrals, we don't mention limits from where to where we integrate. In definite integrals, we mention the limits. We mention the lower limit as a, we are mentioning the upper limit as b. It means what? This x, the x lies between a to b. The value of x lies between a to b. We are taking or can take less than or equal to. It means what? We are integrating this function for the value of x which lies between a and b. So this is the difference between indefinite integrals and definite integrals. Now let's do one thing. Let's see the method to find antiderivative or the integration or integral of a few simple functions using the first method. The method is called as inspection method. Okay. Okay. So let's see the first method here, that is called as inspection method. Okay, let's take the first question here. Okay, find integration of sine 2x dx by, okay, by inspection method. By inspection method. Now what is inspection method? Now see, we need to find what? Integration of sine 2x with respect to x. Inspection means, as I told, what integration is reverse process of what? Differentiation. In inspection method, what you should do is think which function I should differentiate so that I get sine term. Differentiation of what term is sine? Differentiation of cos is minus sine. Right. So what I will do, I'll write d by dx means differentiation of cos. Differentiation of cos 2x, because we have 2x term here. D by dx of cos 2x. Differentiation of cos 2x is what? Minus sine 2x. And differentiation of 2x is what? 2. Right. So d by dx of cos 2x equals to minus 2 sine 2x. Differentiation of cos is minus sine and 2x differentiation is 2. Now what I should do? I should keep sine 2x only here on the RHS. So what I will do is, I'll write it d by dx of, I'll write this minus here, or it's like multiplying by minus on both sides. Now here minus into minus will become plus sine 2x we get. Also I'll take this 2 here. Here 2 is multiplied. If I take it here, it becomes divided. So we get minus 1 by 2 d by dx of what? Cos 2x. Right. Now you do one thing. You take minus 1 by 2 inside. So we get d by dx of minus 1 by 2 cos 2x is nothing but what? Sine 2x. So what we got? we got differentiation of minus 1 by 2 cos 2x is nothing but sin 2x. This means what? Integration or antiderivative of sin 2x should be equal to minus 1 by 2 cos 2x, because I told integration is reverse process of what? Differentiation. So what I will do? I'll write here. Therefore, antiderivative of sin 2x is minus 1 by 2 cos 2x. So this method is called as inspection method. We are inspecting or we are searching for a function, okay, to differentiate so as to get this given function, right? So this method is called as what? Inspection method. Let's see few more problems based on inspection method. Let's say one more problem. Let's solve one more problem based on inspection method. Let's say 3x square dx. Let's say we want to find integral of this function 3x square dx. Okay, using what? Inspection method. Now see here, d by dx of what function? D by dx of what function you should do so as to get x square term? So as to get x square term. See, if you differentiate x cube term, you get x square. If you differentiate x raised to 4, you get x cube. Right? So I should differentiate x cube term here. If I differentiate x cube, I get what? Differentiation of x cube is 3x square. Right? D by dx of x cube is what? 3x square. Now here we have 3x square only. So it's a direct question. Right? So what's the antiderivative then? Antiderivative of 3x square is what? X cube. It's a direct question. Antiderivative of 3x square is nothing but x cube. Right. Let's take one more example. Let's take one more example. Integration of, let's say you want to find, let's take it as 3x cube dx. Let's say you want to find integration of 3x cube. What we should do? See, you should differentiate x raised to 4 term to get x cube term. Differentiation of x raised to 4 is 4x cube. Right? So what I will do? I'll just take 4 here. We get what? 1 by 4 d by dx of x raised to 4 equals to, we get what? X cube. But here we have 3x cube. Here we got x cube. So what to do? Multiply by 3 on both sides. Right? So it implies, I'll multiply by 3 here. 3 by 4 d by dx of x raised to 4 equals to 3x cube. I am multiplying by 3 on both the sides. Now take this 3 by 4 inside. What do you get? D by dx of 3 by 4 x raised to 4 equals to 3x cube. Right? D by dx of 3 by 4 x raised to 4 is nothing but 3x cube. So we got this. It means what? Antiderivative of 3x cube is nothing but 3 by 4 x raised to 4. So therefore antiderivative of 3x cube is 3 by 4 x raised to 4. That's how we find what? We find antiderivative of 3x cube. Let's take one more example. What if the Give an example is what I mean. It consists of, let's say, the two sum of the two functions. Let's say you want to find antiderivative of sine 2x plus x cube. Let's say you want to find integration of this sine 2x plus x cube. So what to do here? So what I will do is, I'll do for this separately, I'll do for this separately. I mean d by dx of, if you want to get sine, you should differentiate cos. Differentiation of cos 2x is nothing but minus 2 sine 2x. Right. Now take this minus here, or it's like multiplying by minus, I told minus, and I'll take 2 here, it becomes divided by 2. We get d by dx of what? Cos 2x. We get it as sine 2x. And I take minus 1 by 2 inside. So we get d by dx of minus 1 by 2 cos 2x is nothing but sine 2x. We got it for sine 2x. Integral of sine 2x is minus 1 by 2 cos 2x. Now let's find it for x cube. Now d by dx of x raised to 4 is nothing but 4x cube. We should differentiate x raised to 4 term to get x cube term. Now take this 4 here, you get what? 1 by 4 d by dx of x raised to 4 equals to x cube. Right, now take 4 inside, d by dx of 1 by 4 x raised to 4 equals to x cube. Right, so let's do one thing. Let's call this as equation 1 and call this as equation 2. As both are differentiations or derivatives with respect to x, let's add equation 1 and 2. I'll write it here. Add 1 and 2. Add 1 and 2. What do you get? D by dx of, add both the terms, minus 1 by 2 cos 2x plus 1 by 4 x raised to 4 minus 1 by 2 cos 2x plus 1 by 4 x raised to 4 equals to sine 2x plus x cube. Sine 2x plus x cube. So we got this function. It means what? Antiderivative of this function is minus 1 by 2 cos 2x plus 1 by 4 x raised to 4. Therefore, antiderivative of sine 2x plus x raised to 3 is minus 1 by 2 cos 2x plus x raised to 4 divided by 4. Right. So this is called inspection method. But the problem with inspection method is, if the function becomes complicated, we can't use inspection method everywhere. Okay, we can't use inspection method everywhere. For that, okay, as we had formulae for what? As we had formulae for differentiation, we also have formulae for what? Integration. So based on that, based on those formulae, and as well as what? As well as based on many methods, okay, we can find integrations of complicated problems also. Right. So let's do one thing. Let's see a few of the formulae of integrations which are used. Okay. Let's see the few of the formulae which are used here in integration. Integration of sin x dx. Integration of sin x is nothing but minus cos x plus c. I told we'll write plus c, constant of integration in case of indefinite integrals. Right. Now second one, integration of cos x dx is nothing but sin x plus c. Third one, integration of sec square x dx is nothing but tan x plus c. Fourth one, integration of cosec square x dx is nothing but minus cot x plus c. Right. Fifth one, integration of sec x into tan x dx is nothing but sec x plus c. Sixth one, integration of cosec x into cot x dx is nothing but minus cosec x plus c. Seventh one, integration of sec x dx is nothing but log of mod of sec x plus tan x plus constant of integration c. Integration of cosec x dx is nothing but log of mod of cosec x minus cot x plus constant of integration c. Now let's see the ninth one. Integration of tan x dx is nothing but log of mod of sec x plus c. Tenth one, integration of cot x dx is nothing but log of mod of sin x plus c. 11th one, integration of x raised to n dx is x raised to n plus 1 by n plus 1 plus c. 12th one, integration of 1 dx is nothing but x plus c. 13th one, integration of 1 by root x dx is nothing but 2 root x plus c. 14th one, integration of 1 by x dx is nothing but log x plus c. Now 15th one, integration of e raised to x dx is nothing but e raised to x plus c. 16th one, integration of a raised to x dx is nothing but a raised to x divided by log a to the base e plus c. Right, we still have a few more formulae. Just look into this. You can just pause the video and you can just look into these formulae, and if you want you can make a list of them also. Okay, now I'll write few more. Seventeenth one, integration of 1 by root of 1 minus x square dx is sin inverse x plus c or minus cos inverse x plus c. 18th one, integration of 1 by 1 plus x square dx is nothing but tan inverse x plus c or minus cot inverse x plus c. 19th one, integration of 1 by x root x square minus 1 dx is nothing but sec inverse x plus c or minus cosec inverse x plus c. Right. 20th one, integration of any constant k into k with respect to x is nothing but kx plus c. Right. So now these are the important formulae which are used in finding the integrals. Okay, few of them, most of them you have seen in differentiation, right? Few of the formulae we can derive it using the next method of integration, that's called as what? Substitution method. Okay, before going to that substitution method, what we should do is we should we'll try to solve few basic problems based on integration. But for that, again, you need to have basics of what? The trigonometric formulae as well as few of the logarithmic formulae. Okay, let me just do one thing. Let me just make a list of those trigonometric formulae and what logarithmic formulae, whichever they are used in integration. So trigonometric formula we'll see. Okay, so first one, sin square theta plus cos square theta equals to 1. Second one, okay, so 1 plus tan square theta equals to sec square theta. Third one, 1 plus cot square theta equals to cosec square theta. Fourth one, sin 2 theta equals to 2 sin theta cos theta. Cos 2 theta equals to cos square theta minus sin square theta. uh, Tan 2 theta equals to 2 tan theta by 1 plus tan square theta. One second, this is 1 minus tan square theta. Seventh one, sine of a plus b is sin a cos b plus cos a sin b. Okay, so sine of a minus b, I'll write here minus. Sine of a minus b is sin a cos b minus cos a sin b. Now let's take the same formula for cos. Cos of a plus b is cos a cos b minus sin a sin b. So for cos, if you have plus here, here you get minus. Now cos of a minus b is nothing but cos a cos b plus sin a sin b. We also use what? Sin a into cos b is nothing but half of sin of a plus b plus sin of a minus b. Okay, so 10th one, cos a into sin b is half of sin of a plus b minus sin of a minus b. Now 11th one, cos a into cos b, half of cos of a plus b plus cos of a minus b. Next 12th one, sin a into sin b, right, minus half of cos of a plus b minus cos of a minus b. Okay, so these are the list of trigonometric formulae whichever they are used. Not just these things, these are important formulae whichever they are used. Okay, and you should know the basic formulae. Sin theta by cos theta is tan theta, cos theta by sin theta is cot theta. You should know those formulae, they are very basic. Now let's see few of the logarithmic formulae whichever they are used. Okay, first one, log m minus log n or log m plus log n. We'll see log m plus log n is log m into n. Okay, log m minus log n, log m minus log n is log m by n. Now third one, log m raised to n is nothing but n log m. I can take this n here, right? Fourth one, okay, log a to the base b is log a to the base e divided by log b to the base e. This is called as change of base rule. Okay, done. Yeah, so these are the few important formulae we use. Okay, one more thing, log of a to the base a is nothing but 1 and log of 1 to the base a is nothing but 0. Log of 1 to any base, any constant a is what? 0. So these are the list of formulae other than integration whichever we use in what? Integration. Okay, so now let's do one thing. Let's pause this video. In the next class we'll start with basic problems on integration. Thank you.